Here are the fundamental identities. The first set of identities are called the reciprocal identities. So we have the big three and the inverses. And the second set of identities are the quotient identities for the tangent and cotangent. So we're going to go ahead and use those identities on this example. So we're giving it the sine of t is 2/5, and the cosine of t is the square root of 21/5. So this angle is going to fall somewhere in quadrant 1 because the sine is positive and the cosine is positive. So I'm just going to write down below what I've been given. And I want to find the 4 remaining trig functions. So let's start with the cosecant of t. If I go up to this previous slide, to find the cosine of t, I take the reciprocal of the sine function. So we're going to reciprocate this 2/5 to be 5/2. Now the secant of t, we go back up. The secant of t is the reciprocal of the cosine function. So we're going to take this fraction and reciprocate it. So we get 5 over the square root of 21. Well, we do have a radical in the denominator, so we can't leave it like that. So we're going to rationalize it. So multiply the numerator and the denominator by the square root of 21. Now we're going to multiply across. 5 times the square root of 21 is 5 square roots of 21. My iPad's not wanting to write here. I'm going to write it down here. 5 square roots of 21. And then in the denominator, the square root of 21 times the square root of 21 is the square root of the square roots cancel out up to 21. The last 2 trig ratios we're going to change to the quotient identity. So the quotient identity says take the sine and divide it by the cosine value. So we have a fraction dividing in another fraction. So we're going to keep the 2/5, we're going to change it to multiplication, and then we're going to flip that second fraction. And now we're going to simplify. Well, we can cancel a common factor of 5. Now we multiply across. Again, in this answer, we have a radical in the denominator, so we're going to rationalize it. So 2 times the square root of 21 is 2 square roots of 21. The denominator, square root of 21 times the square root of 21 is 21. The last trig function, we can have 2 choices. We can use the quotient identity, or if we already know the tangent function, we can reciprocate to find the cotangent. Whoa! And that's what I'm going to do. I'm going to take this final answer and I'm going to reciprocate it. Now I need to rationalize it. And then multiply across. So I get 21 square roots of 21 over 2 times 21. And then we have a common factor of 21. So final answer is the square root of 21 over 2. All right, now we're going to introduce you the Pythagorean identities. So this equation should look familiar to you. It's the equation for the unit circle. When it goes through the origin, it starts, All right, so imagine this is your coordinate plane, and you have your unit circle, and then you have an ordered pair, let's say x and y. This represents your cosine value and then your sine value. So we can use those 2 pieces of information to substitute the cosine and sine in for x and y. So here are the 3 Pythagorean identities. This one is the most popular of the three, and you'll use it quite often compared to the other two. All right, so we're going to go ahead and find the cosine of t using the Pythagorean identity. So we've been given that the sine of t is 2/5 or 3/5, and the angle falls in the first quadrant. So here is 0 radians. Here's pi over 2. This angle falls somewhere in there. So we're going to use the first Pythagorean identity right here. Let's go ahead and write that down. And now we're going to substitute this 3/5 into the equation. Please note that the sine squared of t is the same thing as sine of t all squared. So let's go ahead and substitute 3/5 in. So we do have to square that number. And then plus cosine squared of t equals 1. And we want to solve this equation for the cosine of t. So we're going to square that 3/5. So 3/5 times 3/5 is 9/25. Then we're going to subtract 9/25 from both sides so that we can isolate that cosine of t. Now we're going to simplify this right side. So these are unlike denominators. So we're going to change that 1 to 25 over 25. 25 divided by 25 is 1. Subtracting 9/25. Now these two fractions are alike. So 25/25 minus 9/25 is 16/25. We do need to undo this squared so that we're left with just a cosine of t. So we're going to square root both sides. Well, the square root of 16 is 4. The square root of 25 is 5. Now notice that there is a plus or minus. We only want to choose the one that is appropriate to the angle that it falls in, and it falls in quadrant 1. So in quadrant 1, the cosine value would have to be a positive number, and the sine value would have to be a positive number. So our final answer then is the cosine of t is going to be a positive 4/5.